Starting off our next unit, okay, we've got section 3.6, which is going to be over dividing polynomials, okay? So what we're going to find out today is that there are two ways to do this, okay? And I would say first hour, it was probably split down the middle. I'd say half of them really like the first way better, and then the other half really like the second way, okay? So hopefully you find a way that works for you. I don't really care which way you prefer, just as long as you're good at one of them, okay? But we're going to learn both, so hopefully you'll understand both. So we're going to start off with just a little warm up here, some basic long division. It's been a while since we've heard about long division. Like elementary school, right? Yeah, it's been a hot minute, okay? So this might be something that you haven't seen for a bit, but hopefully it comes back to you. We're going to do this first example together. The way we would set this up, it is 47 divided by 5. So the 47 goes in the little box, the 5 goes on the outside. What? Why? Because that's how we do long division. Okay, so we are dividing by a single digit here. So we first just start with the first digit. Can 5 go into 4 evenly? No. So now we're going to go ahead and consider both digits. Will 5 go into 47? How many times? 9. Okay, then we take that 9, we multiply it back by the divisor of 5. What is 9 times 5? 45. Okay. Then we would change the sign of that 45, make it negative, and we would subtract these two things. So what is 47 minus 45? 2.
And make a 0.
Okay, so then if we were going to do decimals, yeah, we'd put the decimal place, we'd add a 0, but we're actually going to go ahead and keep this in fractions today, okay? So my final answer here is going to be 9. My remainder is 2. And I put that remainder over the divisor. So this is the same thing as 9 2/5. If you did the decimal way, you'd get 9.4, which is the exact same thing.
Do we have to write a fraction form?
Yes, I would prefer the fraction form because that's the way we're going to do the polynomials. Yep, good question. Okay. Example 2. Go ahead and try this one. Set it up, okay? You can use a calculator to check, but when we start doing the division of polynomials, you can't type those into a calculator, so don't get dependent on that. Just try this one on your own by hand. Okay, I like what I'm seeing here. So a lot of us have at least set it up correctly. Most of us have gotten a pretty good start, okay? So we are dividing by a singular digit, so we'll go digit by digit here. We'll start with that 8. Will 7 go into 8? How many times? 1. Then we take that 1 and we multiply it by the divisor. What is 1 times 7? 7. And what do I have to do with that 7?
Subtract.
Yep, subtract it. Change its sign. What is 8 minus 7? 1. What is the next step here?
Bring down the 7.
Yes, we got to bring down that next number. Good. So now we are doing 17 divided by 7, which is 2. We're going to take that 2 and multiply it by the divisor of 7, and that is 14. Change the sign on that 14. What is 7 minus 14? 3. And bring down the 3. This one had a few more steps. Okay. Now we take that 33, divide it by your divisor. What's 33 divided by 7? How many times will it go in there? 4. And 4 times 7 is 28. Change the sign on that 28. Leaves me with the remainder of 5. Okay. How many of us got that? Good. Any questions? Did I go too fast for anybody? Okay, so the final answer, we're not quite done. The final answer would be what? 124 and 5 over 7. The remainder over the divisor. Good. Questions there? Okay, so if the calculator saved you on that one, awesome. It can't save you on this one though. Okay, we can't type x's into our calculator. So we go to set this one up. We got 2x squared divided by x. Okay, this one looks a little different, doesn't it?
Yeah.
Yeah. How many times will x go into the term 2x squared?
Twice.
So let's think about this. We're dividing, okay? So if we went ahead and set it up like this, would this be a little prettier?
Yes.
Yeah. What would happen here? What would stay on top? The 2, it's not going away. And then what would those x's do? X squared over x. No, not going to cancel. Subtract the exponents, right? So if I have x squared over x, it just becomes x to the first, or just x, yeah. That's it. That's all that will do. So technically, x goes into 2x squared 2x times. Does that make sense? We do the same process here now. We take that 2x, we multiply it by the divisor. What is 2x times x? 2x squared, so that matches, which is exactly what I wanted it to do. I change its sign, and I get a remainder of 0. Okay, so the answer to this would just be 2x. What does it mean to have a remainder of 0? It goes into it evenly. Yes, it is what we call factor. Okay, it's a factor if it goes in evenly. Okay, it's going to be important today. So, we're going to get into some longer ones now. We go to part A. I'm going to walk you through this one. So I really need everybody paying attention. This is a process, and if you don't pay attention and you zone out, you're going to be very lost today. Okay, we set it up the same. So x squared plus 3x minus 12 is going to go on the inside, and then x minus 2 is our divisor, and it's going to go on the outside. Okay, this process, one of the main things that I want you to keep replaying in your head, okay, is that we do first term divided by first term. Okay, what I mean by that is that I'm taking my first term underneath, x squared, and I'm going to divide that by my first term of my divisor. So what is x squared divided by x? It is just x. So I'm going to place that up top. You'll notice I placed it above the 3x. Is that super important? No, but it's proper to place something over the exponent that it would match. Okay, so that's kind of the habit I'd like you to get in. So we put that up there. Okay, and now we're going to do the same thing as what we did with the numbers. Okay, so we take that number up top and we're going to multiply it by the divisor. But I've got 2 terms in this divisor. Okay, so I'm going to multiply this out twice. So we'll do x times x, which is x squared, and then we'll do x times negative 2. Negative 2x. Okay. When we had the numbers, what was the next thing we had to do to get this to subtract? I kind of gave it away. We had to change the sign, right? Okay. We've got to do the same thing here. The thing we have to remember, though, is if we change the sign of one term, we got to do it on the other as well. Okay. So we're going to change this to be a negative x squared and a positive 2x. When we do this now, x squared minus x squared is just going to cancel. Okay? Just going to cancel out. That's the whole point of this. We want that to happen. Okay? If that doesn't happen, we need to go back. And now we're just going to do 3x plus 2x, which is 5x. Okay. Now, just like if we were dealing with numbers, we bring down our next term, our next digit, and we repeat this process. So we're going to take our first term divided by our first term. So now we're doing 5x divided by x, which is 5. And now we're going to take that 5 and we're going to multiply it by our divisor. So we do 5 times x, which is 5x. 5 times negative 2, negative 10. We've got to flip those signs. The 5x's are going to cancel. Thank goodness. That's what I wanted. And then we've got negative 12 plus 10. Negative 2. Okay. So I don't have any more digits to bring down, right? I'm left with one term. I'm dividing by 2. So I'm done there, okay? My final answer, though, is going to be just like what it was with the numbers, okay? So whatever's left up top, in this case, x plus 5, that's a part of my final answer. We also have a remainder on this one. Just like on the last one where we took that remainder and we put it over the divisor, we're doing the same thing. So this is just x plus 5 plus negative 2 over x minus 2. That's my final answer. If you have a remainder of 0, you don't need to write a remainder. You don't need to write plus 0 on anything. Okay, but if you have a remainder that is not 0, you have to do that. Any questions on this? Okay, part B. I would like you to just set this up and try to do the first step and then pause. So set this up and then do first term divided by first term, multiply it out, see what we got. Okay, so we should have set it up like this. Do we all at least make it that far? Yeah, we got it set up. Okay. Now we go to first step, which is what? First term divided by? First term. Okay, what am I dividing here?
X cubed.
Yep, divided by x, which is x squared. And where am I going to place that?
Over the 3x squared.
You got it. What am I going to do with him now?
Multiply.
Multiply by the
X
x and the
plus
plus 4. Yep, the divisor. Okay, so we do x squared times x, which is
X cubed.
x cubed. That matches perfectly. That's what I wanted. And then we do x squared times 4, which is 4x squared. You got it. Okay, good deal. Next big step. Flip the signs. You got it. Make them both negative in this case. X cubes, what do they do? Yep, they're going to be gone. And what is 3x squared minus 4x squared? Negative x squared or negative 1x squared, whichever way you wrote it, doesn't matter. Okay. Now what? Yep, bring down one term at a time. We just need 2 at a time. Okay. And now we just repeat, right? Repeat that whole process. So we're going to do our, first term divided by first term. So what is negative x squared divided by x? Negative x. Good. We take him and we multiply him out. So negative x times x is negative x squared, and negative x times, 4 is negative 4x. You got it. Now what? Flip them. The x squares are going to be gone. Yup, cancel. What is negative 6x plus 4x? Negative 2x. Now what? Bring down the negative 7. Getting closer. Repeat one more time. Yup. What are we dividing? Negative 2x divided by x, which is minus 2. Multiply back out. Negative 2 times x. And negative 2 times 4. Do what with the signs? Flip them. The 2x's will cancel, and my remainder will be 1. Okay, go ahead and write what the final answer is and box it in for me. Write what the final answer is going to be. And what is it?
X squared minus X minus 2 plus 1 over X plus 4.
I like it. We all agree with that?
Would you get it wrong if you did plus 1 over?
Yeah, because technically that would be multiplying if you didn't have the plus sign there. Good question. Any other questions? Okay. Let's just be honest with each other. These are ugly, aren't they? Yeah, these are super ugly answers. Okay, so when you start doing your homework today and you start getting some things that are not pretty, don't think you're doing it wrong. Okay, because chances are a lot of these answers are going to be ugly like that.
Can we skip C?
Yeah, we're going to skip C. Okay. We've already kind of talked about this. Something is considered a factor if the remainder is 0. Okay, so these might be really good like EOC or ACT questions. Okay, determine if the following are factors. Is x plus 4 a factor of that polynomial right there? Okay, so how would I find that out? Divide it and then, yeah, if it comes out to 0, then it is a factor, and if it comes out to anything besides 0, it's not a factor. Okay, so I'll set up this first one for you. We're just doing that exact same process here. Okay, and your job now is you're doing examples 1 and 2. I set up example 1 for you. So go ahead and try them, compare with your group. Here we go. Okay, I saw a lot of people that were either on the right track or had the right answer, so I appreciate that. What is our first step here? First term divided by first term. What is x squared divided by x? You can even write it over here if that helps you. What is it? X. So that needs to be placed up top. Okay. Once we have the guy up top, what happens to him?
You multiply by the.
Yeah, multiply him by the divisor. There's 2 terms in the divisor, so he's got to multiply twice. So x times x is, and x times 4 is 4x. Flip the signs. You got it. When we do that, the x squareds are going to cancel. And what is 6x minus 4x? 2x. Yep, it should be positive 2x. And now what?
Bring down the plus 8.
Bring down the plus 8.
And then first thing, the first thing.
Yep, first term divided by first term, which is 2.
2.
So plus 2, right?
Yeah.
And then since he's up top, he gets multiplied by both terms in the divisor. So 2 times x is,
2x.
and 2 times is,
Negative 8.
not yet. It's not negative yet. It's still positive. Now we need to flip the signs and make it negative. Okay? So the 2x's will cancel, and 8 minus 8 also cancels to give me a remainder of 0. Is x plus 4 a factor?
Yes.
Yes. What's the other factor? X plus 2. Okay, we just got both factors here. Okay? How many factors should I have on this problem? 2, and how do you know that?
Oh.
Highest exponent. The highest exponent in any polynomial is how many factors it should have. Okay, so if this one's got a highest exponent of 2, it should have 2 factors, and we just found both. Okay, something to keep in your mind for the back, or for the rest of this unit. Okay, example 2, this one you guys said was a little rockier. So let's be sure we're paying attention. Okay, hopefully we at least got it set up right.
Yeah.
Okay, walk me through it. What are we doing?
First term.
Okay, so that is what?
3x squared.
3x to the third divided by x, which is 3x squared, Olivia tells us. I agree. Okay, if you can't do that in your head, go write it over here. There's nothing wrong with that. See what's going to happen. Okay, it's going to be a 3. The exponents subtract. That's how we get 3x squared. Okay, you don't have to do that, but that's just a way to visualize it. Okay? Now what?
Now you multiply by
Yeah, multiply it out. 3x squared times x.
3x cubed.
Good, it matches that term, just like it's supposed to. 3x squared times 1 is,
3x squared.
okay? Flip the signs, I like it. The first terms are going to cancel out. And what's 4x squared minus 3x squared? Just x squared or 1x squared. Now what?
You bring the plus 2x down.
Yep, bring down plus 2x. And repeat. What are we dividing? Okay, x squared divided by x is x, I agree. Multiply it out, x times x. X times 1. X. Now we flip the signs. The first two, 2x minus 1x. X, and I don't know why you guys said this was rockier. You know how to do it.
I just did it wrong.
Okay. And lastly, our last process here. First term, x divided by x. What's anything divided by itself? Yes, it is 1. It is not 0. Please don't do that. Okay. Multiply it out. 1 times x. X and 1 times 1.
Oh, I stopped right here.
You stopped right here. This is where a lot of people stop and they end up getting it wrong by accident. Okay. You got to do what now? Flip the sign. So this does not give me a remainder of 0. What's my remainder?
2.
Negative 2. Watch your signs. Is x plus 1 a factor of that polynomial? No. It has a remainder that's not 0. Are we clear on this?
So we don't have to write the whole problem?
Not when it's just asking you a yes or no question. You don't. Nope. Okay. Any questions for me before we move on from this process? How do we feel about this process?
Wait, so how did you get the 3x on
Some of us are feeling good. Okay. How did I get the 3x on top in the first place? The 3x squared?
Yeah, 3x
Because that was our first term, 3x to the third divided by our first term of x.
divided by x.
3x to the third divided by x is 3x squared.
Okay, so this, okay.
Yep, you got to keep the coefficients
Okay.
in your division problem.
Alright, I'm good now.
Okay, any other questions? Hi. Whoa. All right. Here is process number 2. Guys, let's turn off the chatter. Okay. So I told you there's 2 ways to divide polynomials. Here is the second way. We call this synthetic division. Okay, what we just did was called the long division method. This is synthetic division. Okay, it's still doing the same thing. It's still taking a big polynomial, dividing it by a factor, and seeing if it has a remainder or not. Okay, how we do this? The first thing we do is we take the big polynomial and we want to write out all of its coefficients or constants in order. So that just means the numbers, not the variables. Okay, so in this case, the first number is 3, and then 4, and then 2, and then -1. Okay? One thing that's important to note on this, we always write our polynomials with the exponents in what kind of order? Starts with a D. Descending, okay? So if I look at this, are these exponents in descending order? Yeah, and am I missing any? So what I mean by that, I go from x cubed to x squared to x to the first to nothing. Did I skip any numbers in that sequence? No, I didn't. Okay, so that means I'm good. I don't have to worry about this one. But if I skipped an exponent, I would have to put a placeholder of 0 in. And we will see that happen today. Okay, so it's not going to happen on this first one, but it might happen at some point today. Okay, once we have that, that's probably the hardest part, is just making sure we don't miss one of those zeros. But once we have that, we set our divisor equal to 0 and solve. This is going to become what we call our ledge guy, is what you're going to hear me refer to it as. So my divisor in this case was just x plus 1, set it equal to 0. What does x equal? Have I solved that? Yeah, just subtract 1, so x would be -1. So that would be my ledge. That would be my ledge guy, okay? And then we drop our first coefficient down, multiply that term and the ledge, and then we add and repeat. Okay, sounds a little more confusing than what it is. Let me show you how this works. So, ledge guy we said was -1. So I'm going to go ahead and I'm going to place him right here in its own little box. He's apart from everybody else on a ledge.
Is it always -1?
Nope, it's setting your divisor equal to 0 and solving. Okay, then I'm going to take those numbers that I found in step 1, which were 3, 4, 2, and -1, and I'm just going to put those across. And leave a little space and draw a line. Okay. Everybody with me so far? Okay, here is the process. Here we go. First step is to drop the first guy down. He's got the easy job. So that 3 is just going to drop down. We take that 3, we multiply it by the ledge. So 3 times -1 is -3. Place them right here. Add them up. 4 plus -3 is 1, not -1. Thank you. Now we repeat. We take the 1 times the ledge guy. 1 times -1 is -1. Place it here. Add them up. 2 plus -1. 1. Take that. Multiply it by the ledge guy. 1 times -1 is -1. Add them up. -1 plus -1. -2. Okay? This will get easier with practice. So, this is actually the answer. Okay? But it doesn't look like the last answers that we had, right? Because it's in disguise right now. What I mean by that is we took all the variables out. Now we got to put them back in. Okay? We're actually going to kind of work backwards on this just so we don't miss any. Okay? So what I mean by that, this last term is always going to be your remainder. Okay? And we always place the remainder over the divisor. So in this case, that was x plus 1. So this is just -2 over x plus 1. Which means working backwards, that would mean 1 was my constant. This 1 would be my x to the first. And then this 3 would be my x squared coefficient. Okay, so this would end up being 3x squared plus 1x plus 1 plus -2 over x plus 1. And if you want to just leave this as x and not 1x, that's fine.
I'm confused.
Okay, we're going to practice it, so let's not get the negative attitudes out yet. We're going to do another one together. Okay. Here we go, here we go. I'm going to switch this up just a little bit as far as the order of what the notes were. I'm going to find the ledge guy first, just because he goes first, okay? So I set my divisor equal to 0. Solve it. What's my ledge going to be? -3. Here he is. Put him in his box. Okay, now I need my numbers going across. So I pay attention to that big polynomial. We start with the first number. What's the first number in front of x to the fourth? 1. Okay? In descending order, what would come after x to the fourth? X to the third. Do you see one? No. So what needs to go there? A 0. Okay? Then would come x squared. Do we have a number there? What is it? Then would come x to the first, which is 1 and nothing. Just a constant, which would be 4. Leave a little space and draw a line. Okay, who has the easiest job? The 1. He just drops down. Okay, now that 1 needs to be multiplied by the ledge guy, which is the -3. 1 times -3 is? -3, add them up. 0 plus -3. Okay, take that -3 back to the ledge. What is -3 times -3? 9. Add them up. 3 plus 9. 12 goes to the ledge. 12 times -3. -36. Add them up. 1 plus -36. Okay, take him to the ledge. -35 times -3. Probably can't do that in your head. 105. And add them up. 105 plus 104, or 4 plus 105. 109. Okay. Big one. What is that 109? Which needs to be over x plus 3, which was my divisor. Good. Okay. Then we work backwards. The -35 is going to be the constant, so it doesn't have any x's. The 12 is going to be the x. Good. The -3 is going to be the x squared, and the 1's going to be x cubed. There she is. That's my answer. Is she pretty? No. Okay. A pretty ugly answer. That's okay. That's okay. We'll have that sometimes. Okay. When using synthetic division, if your remainder is what? Then it's a factor. 0. This is the same as long division. Okay, it works the exact same way. If you get a remainder of 0, voila, you found a factor. Okay, example 2. Set it up and do this one. Okay, use that example that we just did. I don't want to see anybody sitting still. It's going to make me mad today. All right, here we go. Ledge guy, who is he? 1, because we said x minus 1 equal to 0. Solve it, and you get 1. Numbers going across, what are they?
2, 1, -4, 2.
We didn't have any placeholders here? No? Okay, cool. No gaps in my descending exponents. Tell me what to do now. Bring down the 2. Multiply by ledge guy. 2 times 1. 2. Now what? Add them up. What is that? 3. What's the 3 going to do? Go to ledge guy. 3 times 1. 3.
-1.
Add them up. -1. -1 goes to ledge guy. What is that? Add them up. 1. What's my final answer?
2x squared plus 3x minus 1 plus 1x over x.
How many of you agree with the crowd? Okay, good deal. Any questions on this? That's everybody. Proud of you. Okay, little poll. Let's take a poll here. How many of you prefer the long division method? How many of you think that was easier? Okay, and then synthetic division? Okay, so we're leaning towards synthetic division in this class. I would say though, like my first hour today, more people liked long division. Okay, so it's just whatever you prefer. I don't care which one, whichever one you're better at. Okay, I want to do one more example. I want to do one more example of this, and then we've got one more thing to cover, and we're done for the day. Okay, what time is it? We got a little bit of time. You will. I am telling you that, Ryan. Okay? So I want you to take example 4 and I want you to do the method you prefer. Do the method you prefer on example 4. Let's test it. We'll have some people do the opposite method. We'll see if we get the same thing. Okay, so either way you did it. This should have been your answer right here. 2x squared plus 11x plus 22 plus 34 over x minus 2. Okay, I will say that the long division on that one, it did actually make you put a little gap there, or else it kind of got a little tricky without doing that. So that might be another thing you consider there if you do the long division on the big ones. Okay? Either way though, that should be our answer. Any questions on either method? Yes.
For the 7 and 4, are we always supposed to add it or are we always supposed to subtract it?
For synthetic division, you're always adding them up. Yep, always adding them up. Good question. Any other questions? Okay. Last little thing. We're almost done. Okay, so we have another theorem here. I guess not another. It's our first one that we've learned so far. Remainder theorem, guys. Here's what I need you to write here. The remainder after synthetic division or long division, really. The remainder after synthetic division equals the evaluation of f of x. Okay, I am going to do synthetic division on this one just because I do think it is easier. How this is going to work, okay? So anytime it gives me something like this, it tells me f of 2 for f of x equals that, okay? So the way that we typically did this, we actually did this in Unit 1, okay? We evaluated numbers. So what we would have done is we would have just plugged in 2 for every single x in that, yeah? Which in this case, that one would have been pretty easy, right? You could have done that in a calculator, okay? And you would get an answer on that. If you want to go ahead and write down what that answer is, do it, but don't shout it out loud, okay? We're actually going to get that same answer if we set up synthetic division and we use the number that it's giving me, which is 2, as my ledge guy, okay? So we'll go ahead and make the 2 that we're plugging in. That's my ledge guy. We'll set up our numbers going across. So in this case, it would be 2, 7, 0, because we're missing an x, and negative 10. Leave a little blank. Hop down the 2. 2 times the ledge. 2 times 2 is 4, 11, 22, 22. It's the same problem, I know. 22 times 22 is 44. And this gives me 34. Okay, so the answer to the evaluation, if you plugged it in your calculator, what we just wrote up top, it should be 34 as well. These two things are always going to be equal. That's the theorem. Okay?
So can we just do that long problem? Like the f of 2?
I don't know about you, but I got 36. I got 34.
You should get 34. Plug it in again. Watch your signs. You put... Did I put third right? Yeah, I put that right. Okay. Okay, that's it. That's all I had to show you. If you want to do the other one and come check it with me, you can. Your homework is on Delta. It's on Canvas, but a Delta link.